Okay, welcome back. Let's take a look at our next lesson, Lesson 2, Atomic Structures. To help you guys out, I've included some videos to help you with the periodic table song. Additionally, I've included another short video to help you memorize the periodic table. You typically are expected to know the first 20 elements, so take a look. Okay, so let's start off with the atomic structure. And again, you guys have the option to print this out if you would like to. So, the atomic structure, a little joke. They told me I could be anything I wanted, so I became everything. And obviously, I taught them about atomic structure, and they said it was boring, because we're going to learn about the Bohr model. Okay, atomic structure, matter is anything that has a mass and takes up space, right? You should have learned that in grade 8. The term atom was used to describe the smallest part of matter that still has the properties of an element. Okay, and then we have the components of an atom that you guys will be studying. So the protons, which are positively charged, our neutrons, our nucleus, which is where the protons and neutrons are stored, and then we have our electrons orbiting it, the nucleus. Okay, matter has both physical properties and chemical properties. And again, those definitions are listed in your vocabulary from lesson 1. Okay, what do you remember about the atomic structure? Match the following subatomic particles to its definitions. So I've already done that for you guys. I just told you that previously about what the protons are and neutrons are and electrons. But if you need a reminder, our electrons are negatively charged, our protons are positively charged, and our neutrons have no charge. Okay, so again, just another visual for you guys. Protons, here's the symbol that we use, a P with a plus sign. A positive 1 charge, we see with the location. Neutrons, an N with a 0, there's no charge, located in the nucleus as well. And then our electrons, which is an E with a dash. And then we have a negative 1 charge, and that's typically in the energy levels. Okay, so Bohr atom. So Niels Bohr proposed that electrons surround a nucleus in specific energy levels, right? And you might have heard that previously in Science 9. In Science 10, you learned about the different energy levels. And then right here, we have 3 protons, so we know we're dealing with lithium. And then we have 4 neutrons, so 3 plus 4, they each have a respective atomic mass of 1, so we're looking at about 7 as an atomic mass, which is 6.941. Okay, what is an element? Well, it's a substance that cannot be broken down into simpler components, typically, but we just learned there are subatomic particles. Only one type of atom is present, defined by the number of protons they possess, found on the periodic table of elements. What are some types of elements? So most of you can probably think of a couple of them. So there are, we have tinfoil or aluminum foil. Here looks like gold. And then we have neon lights, and neon is a noble gas, and various other gases give off different colors when current or charges are ran through them. So again, different examples of elements. We have aluminum, gold, neon, copper, iron, and chlorine gas. Basically anything on the periodic table. Okay, so if you had the opportunity to print this out, what you can do is you can look at circling the different periods on the table in blue. If you want, you can also circle the different groups on the table in red. And then you can draw the staircase line in green. And then you'll have the option to label the metals and non-metals. The analogy that I always use is metals are losers because they lose electrons, and then non-metals typically gain electrons. And then for those of you who maybe didn't have the opportunity to do it, here you go. So here we have our groups. Groups are the vertical lines right here. So we have our alkali metals and we have our alkali earth metals. We have our noble gases, we have our halogens, we have our transition metals, etc. We have our groups which are horizontal, sorry, our periods which are horizontal. And then we have our green line, which is the staircase. So along this staircase, we have our metalloids, which are some of these elements have properties of metals and nonmetals. So we'll get a little bit more into that later. But typically, our metals are to the left of that staircase, and then our nonmetals are to the right of that staircase. Okay, so if you've taken a chance to watch that video that I've posted, feel free to label these different families. So the alkali earth metals, the transition metals, the metalloids, the halogens, and the noble gases. Feel free to pause and do that. And if you have, ta-da, here you go. So we have our alkali metals here in group 1, alkali earth metals in group 2. We have our transition metals right here. And then we have our halogens right here and our noble gases over here. And again, metalloids touch the staircase and have properties of metals and nonmetals. So how do we read the periodic table boxes? Well, the atomic number is typically on the left-hand side, and that tells us the number of protons and electrons in a neutral atom. On the right, we typically have the IUPAC symbol, and it's usually 1 or 2 letters that indicate what the substance is. Sometimes they might not quite make sense. So sodium is Na, and that comes from the Latin name. We have the average atomic mass, which includes typically our isotopes or different versions or types of that element. And then we have an ionic form, which is where we have some of the different charges where it may have a positive or a negative charge, depending on if it's a metal or a non-metal. If it's a metal, it typically has a positive charge because metals lose electrons. And then if it is a non-metal, it typically has a negative charge because it gains electrons. Okay, so again, I have a couple of examples for you guys. If you would like some practice questions, they are in a data booklet for you guys. Just let me know, and I can forward that to you guys as well. And then from here, we have some practice questions for you guys. Okay, so feel free to pause and to give these a go. And that's exactly what will be happening. So you'll have to name their IUPAC symbols, which is 1 or 2 letters. The first one is always capitalized. The second one is lowercase. The atomic number, which is the number of protons. The group number, the period number. Is it a metal? Is it a non-metal? What is its state at standard atmospheric temperature and pressure? What is the family / series names? Chlorine is Cl. There are 17 protons. The group number is also 17. The period number is 3. It is a nonmetal. It is a gas, and it belongs to the halogens. Okay, so there are a number of examples for you guys to go through. And you'll see that I've also given you guys the answers. Okay. What is an ion? Well, it's an atom or an element that has a net electrical charge due to the loss or gain of electrons. Okay, and here we have a Lewis dot diagram to kind of help you out. And if you're not sure about what Lewis dot diagrams are, maybe I'll post an additional video in here to help you guys out. But essentially, if an atom loses electrons, which is typically our metals, it's going to become more positive because you're losing negative things. And if an atom gains electrons, it typically becomes more negative. So here we have a sodium atom. There are 11 protons, 11 neutrons. It has a neutral charge. in its outer valence shell, it loses an electron. Therefore, we now have 11 protons, 10 electrons. The net charge is going to be positive, positive 1. Okay, quick little summary for you guys. There are 3 subatomic particles that make up an atom: protons, neutrons, and electrons. Protons and neutrons are found in the nucleus or the center. You cannot gain or lose protons. If you gain or lose protons, you actually change the element. However, you can gain or lose neutrons, which we did not talk about, and that's what happens when we create an isotope. So an example would be carbon 12 versus carbon 13 versus carbon 14. Electrons orbit the nucleus and have very little mass, so we typically say the mass of the electrons are negligible, and electrons can be lost or gained to form ions. So a quick little practice problem for you guys. Feel free to pause and to answer the following questions. And once again, I've given you the answers. So the atomic number is 26. So there are 26 protons with Fe, which is iron. What is the atomic mass? It's 55.85. Most common ion, well, the most common ion is iron 3. Number of electrons in the atom, well, it's 26. It's going to be equal to the amount of protons. Number of protons, that's going to be equal to the atomic mass, or sorry, the atomic number, which is 26. Number of neutrons in most common isotope, so we have a atomic mass of approximately 56. We round that up, so 56 minus 26 gives us 30 neutrons. Okay, so this should all be a review of grade 10 and probably grade 9. Okay, and if you need more practice with that, just let me know and I'll post more stuff for you. Number of valence electrons in a least common ion, 2 less than full, right? Because it's going to be plus 2. Okay, so these can be completed on paper, or if you've printed out the digital slides, feel free to do that as well. And as always, I've given you some of the answers with arsenic, right? There's a -3 ion, so we gained 3 electrons. And I've gone through all of them for you. Okay, what are special atoms? So probably when you were in grade 9 and grade 10 and you're naming compounds, you learned about the IUPAC naming system. So the prefix di means 2. So diatomic elements consist of 2 of the same atoms that are bonded together. So you have hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodide. They typically exist in groups of 2. And I believe there's a mnemonic that will help you remember these. I just know them, but might help you guys out if I can remember that mnemonic. Okay, what are special atoms? So they're polyatomic elements, so they consist of more than 2. Okay, so some of these guys are a little tricky. You typically are given these on a periodic table for your assessments. You typically don't have to memorize them. So I wouldn't stress memorizing them. I'm pretty sure you get them, so I wouldn't stress them. But if you recognize them, obviously sulfur, you're looking at 8 sulfur ions, and then phosphorus looking at 4, and so on and so forth. Okay, found in a chart on your periodic table. Like I said, you'll get these if you ever need them. They'll be on your periodic table for you guys. So you just need to kind of recognize them and go, oh, we have a sulfite polyatomic ion. What is the net charge? Well, it's -2. Okay, so once you've reviewed your videos, you're now ready for quiz 2. See you later.